Hello, my name is Ardi, and here the question is find I1, I2, and I3 in this figure. What is I1, what is I2, and what is I3? It is this current here. I1 is this current here, I2 is this current here, and I3 is the current here. But before we step further, I think I need to put some sign in the resistance here, and also let's analyze what can we infer from this figure. Okay. So now let's trace this I1. I1 is going to the right, and obviously it will pass through this 10 volt battery and this 6 ohm resistor. So the current that passed through this 6 ohm resistor is also I1, right? And it goes to the right. But I want to give label to the polarity of this resistor. How? Well, the current goes in from this side, so this one will be the positive side, and where the current goes out is the negative one. So here is the negative one. Okay, and remember that is our convention. Convention. So where the current comes from, it is the positive side, and then where the current goes to, it is the negative side. Okay, let's apply all of that to all the resistor. So I2 is going here, and it is coming from here, and it also passed through this resistor, right? This is I2. And let's apply our convention here. Where the current comes from is the positive side, and where the current goes to is the negative side. Good. And here we also have I3. I3 is going down, and then it will goes to the left here. So this current is I3. And now let's label the polarity of the resistor. So where the current came from is the positive side, and where the current goes to is the negative side. Okay, this will be very helpful in applying loop rules, because here, okay, let's label our loop here. So I will label this one loop here as loop 1, and I also label this loop here as loop 2. And the sign of the resistor will be very helpful to analyze both loops. But first, I want to apply the junction rule first, where here in the point C, right? Let's apply the junction rule. So the Kirchhoff junction rule at point C. What does the junction rule say? It said that the sum of the current that goes in will equal to the current that goes out. And the only current that goes into this point C is I1. So I will have I1 here. Okay, and then that will equal to the current that goes out. Oh, I think there are more currents that goes in. So I will have I1 goes in and I2 also goes in. So I will have I1 plus I2. And that will equal to the current that goes out, which is I3. So I1 plus I2 is equal to I3. And I think nothing that we can do from here. Let's save this as equation number 1. Okay, now let's remember the loop rule. The loop rule said that the sum of the voltage in a loop is equal to 0. But here we have some resistor here. To get the voltage from this resistor, we have to remember the Ohm's law. So let's remember the Ohm's law first. Ohm's law. Ohm's law said that the potential difference in a resistor here, so I will have delta V is equal to the current multiplied by the resistance. Okay, this will be very helpful later. Okay, now let's do the loop rule at loop 1. Loop rule at loop 1. Okay, what does the loop rule say? It says that the sum of the voltage in a loop will equal to 0. Good. Now let's see loop 1 first. Okay, let's start from this battery here, 14-volt battery. The loop will enter from the positive side, so I will have plus. So we have the positive sign here, and it is already voltage, right? That will be 14 volt. So I will have plus 14. And then let's move on. So the loop will goes into this resistor here, but it is entering from the negative side. So I will have minus sign. But then we have resistor here, so we need to apply the Ohm's law here, which is the current times resistor. And what is the current? This current is I1, so I will have I1. And then multiplied by the resistance, which is 6 ohm. So I will have 6 here. Okay, now let's move on to this 10-volt voltage source. And this loop will enter into positive side. So I will have plus, and then the value of the voltage is 10 volt. So I will have 10 there, right? Good. And then for the last resistor, we have this 4 ohm. And the loop will enter from the positive side. So I will have positive sign. So we will have plus. And then the voltage here is current times resistor. So I will have I2 here as the current. And then the resistance is 4 ohm. So I will have 4. And I think we have circle out the loop. So I will have 0 on the right hand side. Okay, we can simplify this. 14 plus 10, that will be 24. And then we will have minus 6I1. And then what else? I will have plus 4I2. All of that will equal to 0. So we will have 6I1. And then minus 4I2. All of that will equal to 24. Or we can simplify this. So we will have 3I1 minus 2I2 is equal to, what is it? 12, right? Because we divide both sides by 2. Good. Now let's move on to another loop rule, but this time at loop 2. So we will have loop rule at loop 2. So what does this mean? Okay, so let's apply this one, that the sum of the potential difference, or we usually call it just voltage, that will equal to 0. But now we are working on loop 2 here. Okay, let's start from that 10-volt battery, and let's use another color. I will use yellow highlighter here. So this loop 2 will enter this battery from the negative side. So I will have, our sign here will be negative. Okay, and then the voltage here is already known, 10 volts. So I'll have minus 10 here. Minus 10. Okay, now let's move on to this resistor. And the loop entering from the positive side. So I will have plus here. Plus, and then remember that we have Ohm's law here. The current is I1. And then the resistance is 6 ohm. So I'll have I1 multiplied by 6. Okay? And now let's move on to the last component, which is this 2 ohm resistor. So the loop will enter from this positive terminal. So we will have plus sign here. And then the current is I3, right? So I will have I3. And then the resistance is 2 ohm. So I will have 2 here. All of that will equal to 0. Okay. And then we will have 6I1. And then plus 2I3. That will equal to 10. Good. But we can have I3 here is I1 plus I2, right? So I will have 6I1 and then plus 2 What is I3? I3 is I1 plus I2. So I will have I1 plus I2, and that will equal to 10. Good. Now we will have 6I1 plus 2I1, and then plus 2I2, and that will equal to 10. So we will have 8I1 plus 2I2, and that will equal to 10. Okay, now let's name this equation is equation number 2, and this equation is equation number 3. And if we see this equation number 2 and equation number 3, they are two equations with two variables. We can solve them, right? Let's solve that. Okay, let's solve 1 and 2. How to solve them? So let's rewrite equation 3 first. I mean not solve 1 and 2, but solve 2 and 3. 2 and 3. 2 and 3. Okay, let's write equation number 3 first, I think, or number 2 first. Let's just write number 2 first. So I will have 3I1 minus 2I2, that will equal to 12. And then we also have 8I1, and then plus 2I2, that will equal to 10, right? We can just add them up, right? And we can get rid of the I2 term. So we will have 11I1, and that will have 22 in the right hand side. So I will have I2 here is 22 divided by 11. No, that will be I1, right? So I1 here is 22 divided by 11, which is 2 ampere, which is very good because this is one of the final value that we are looking for. I1 is 2 ampere. Okay, let's highlight that. So this is our I1. And how to find out I2? Just plug that into equation number 2 here, right? So let's do that. So I will have 3I1, but I1 is equal to 2. And then we will have minus 2I2, right? 2I2, and that will equal to 12. Good. So I will have 6 minus 2I2, and that will equal to 12, or minus 2I2. Now will equal to 12 minus 6, which is 6. And so we will have I2 is equal to minus 3 ampere. Okay, which is nice because this is also the second value that we are looking for. Okay, good. And we can also highlight that. But then from here we can just add them up, right? Because I1 plus I2 is equal to I3. So what is I3? I3 here is equal to 2 plus minus 3. So I have 2 plus minus 3. So we will have I3 is equal to minus 1 ampere. And that is the final value that we are looking for. Okay, hopefully I did not make any mistakes throughout the calculation. I think I did not make any mistakes because this is exactly the answer in the book. Okay, thank you for watching. See you in the next video. Bye-bye.